If you're a developer, you know the absolute drag of context switching. You're deep in the zone, writing code, and then you need to test a quick API endpoint. Suddenly, boom, you break your flow just to fire up a totally separate app. Well, welcome to This Explainer. Today, we're checking out a real game changer, a revelatory shortcut that completely eliminates that friction.
It's a serious question, right? Why open Postman, or honestly any other bloated GUI tool, when the editor you already have open can do the exact same thing? Look, over the years, external API clients have gotten super feature-rich, but man, they are heavy. You gotta sync accounts, manage workspaces, and worry about losing those workspaces, literally just to fire off a simple test.
The old way is kind of chaotic. It's this tab-heavy workflow where you're bouncing from browser docs over to Postman to craft the request, and then back to VS Code to tweak your backend. Now, contrast that with the new way, VS Code Native. We're talking zero context switching here. It's a streamlined, Git-friendly alternative that keeps your focus exactly where it belongs, on your code.
Your first HTTP request.
So how do we actually make this zero context switching workflow a reality? Well, the setup is ultra fast. First, open your extensions, search for REST client by Huaqiao Mao, and hit install. Next, just create a new file and end it in .http. Finally, you just type your request in plain text and click the Send Request button that basically magically appears right above your code. You stay incredibly close to your code base the whole time.
Picture this. You're in that sleek, dark-themed VS Code editor. You zoom in, and this is literally all you write. Get https:/httpbin.org/get. That's it. No GUI buttons, no clunky drop-down menus to select your method. You just click the little Send Request text hovering above line 1, and bam, your response opens instantly in a split pane right next to your code.
And handling more complex calls? Just as elegant. To write a POST request, you just type POST, add your URL, drop down a line for your headers, something like content type, application JSON. Leave one blank line, and then just write out your JSON body. It's completely plain text and perfectly readable. No digging through tabs to find where the payload goes.
But here's a crucial syntax rule from the docs you absolutely cannot miss. When you want to put multiple requests into a single file, you must use 3 hash marks, hash, 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 as the delimiter to separate them. A lot of developers try to use 3 dashes, because they're used to Markdown, but actually, scratch that, dashes will throw a parsing error, because they can be read as part of a JSON body. So always use the 3 hashes. It's a lifesaver.
Key point 2. Switching API environments.
Okay, so basic requests are easy, but let's talk about the real magic features, like solving that universal headache of testing the exact same API across your local machine, a staging server, and production. You configure your environments right inside your VS Code workspace settings, your settings.json file. You define a dev host and a prod host. Then in your .http file, you simply write get and then host wrapped in double curly braces /API. The extension dynamically injects the correct URL based on your selected environment. Literally one line change for endless flexibility.
You can effortlessly switch between these environments using the shortcut Ctrl-Alt-E or Command-Alt-E on a Mac, but listen. Here is the absolute most crucial point. Because your settings.json might now hold sensitive stuff like API tokens or passwords, you absolutely must add it to your .gitignore file. Keep those secrets out of source control for sure.
Key point 3. Chaining authenticated requests. Once your environments are locked down securely, we can tackle one of the most annoying parts of API testing. This brings us to request chaining. So, what does this actually mean? It's the ability to automatically grab a value from one API response and inject it directly into a subsequent request. If you're testing complex OAuth flows or authenticated endpoints, this feature alone is going to save you hours of manual copying and pasting. In practice, it is remarkably simple. You just add a comment above your first request giving it a name, like #@name-login. Then, in your next request, you dynamically reference it in your authorization header. So you type login.response.body.token. The extension executes the login, parses the JSON, extracts the token, and fires it right into the second request. It's pure magic.
Key point 4, APIs as living documentation.
Let's shift our perspective for a second to the long-term paradigm shift here. Beyond the immediate fast testing benefits, there's a massive upgrade for team collaboration and version control. I want to read this quote from one of our sources because it really hits the nail on the head. What I appreciate most about REST Client is how it keeps my API requests alongside my codebase, ensuring everyone works with consistent API calls. Because these are just plain text files, you commit them right into your Git repo. You're treating your API calls as version-controlled, living documentation.
Real support scenario, webhook debunning. To really ground all these features, let's look at a high-stakes engineering scenario. Imagine it's a Friday afternoon, the worst time, right? And the pager goes off. A webhook delivery failure just happened in staging. Let's walk through the exact chronological timeline of how an engineer investigates this failure using only their editor. First, the delivery fails. Second, the engineer writes the exact payload into a .http file. Third, they replay it to capture the error. And fourth, they commit that file as concrete evidence. So for step 2, the engineer quickly spins up a file, sets the environment to staging using that staging URL variable we talked about, and pastes the exact failing JSON payload into the request body. No browser, no app switching, they just hit send request.
Instantly, the engineer captures the precise 400 bad request response, clearly showing a validation error for a missing user_ID. The bug is isolated immediately, literally right inside the environment where the fix is going to be written.
Why is this workflow so incredibly powerful? Because there was zero context switching during a critical investigation. The payload and the error state are now fully reproducible for anyone else on the team. And best of all, the engineer commits that exact .http file to their Git branch as reproducible evidence of the bug and the eventual fix.
Which brings us to the end of our explainer with a pretty provocative question for you to consider. Is your current API tool actually helping your codebase thrive? Or is it just acting as a silo, kind of hoarding your requests away from your team? If you want living documentation, zero context switching, and a way more streamlined workflow, it might be time to test your next API directly inside your editor. Thanks for joining me on this explainer, and I hope this sparks a massive upgrade to your own development workflow.